So this is just the various sizes. They can range anywhere. There's some that are small. This is medium to large size. In the actual process, cut off this middle stem. That's to allow airflow. If there is no airflow, Great. You just explained it. It's theoretical, right? Where we plant. It's just because yeah, it is very clean. It looks. Congratulations. We have no wiring coming out anywhere. And honestly, the only issue you could ever see really innovating is just the rivets on the edge.
Okay.
But that can easily, you get some also.
We are here.
Are we? Awesome. This is here.
So,
and there was
that's this one.
should change the
So, yeah, it should be.
oh, where are the numbers on those? Let's see. So 16056 is this group, which is here. So I think we need to be over in this guy for whatever group that is.
When I called it in, they're like, oh, that was Josh.
Oh.
Hey,
how are you?
good. How's it going?
We brought a vehicle. What's done is done. There's not much you can do about it.
The antennas, like the pies, we're having trouble because every time you turn off the antennas, they reconfigure themselves. So we're having trouble accessing the pie in there. So we're setting up another network to get into it. So it works, and we've tested it, and we can show you that we'll update the database. And then let me see if I can.
I got you.
Yeah, it looks like networking issues. So if we go here.
We're going to need a lot more time.
Oh wait, so
That's what I'm doing. Change it to that.
This is what it ended up looking like. Doesn't look the prettiest.
We're really trying to find you out here. Really similar shirts. Yours is bigger than mine.
Worked out really well.
Systems industrial engineering.
Whoa.
And engineering management.
Yeah, so I'll be on the side of it.
I mean, we can, but it would be like.
This one's nice.
Oh, it's out here? Okay. Yeah, this is ours.
Oh, I like your lightsaber.
There's another lightsaber back there.
So then it could be mounted standing up like this.
Dude. Oh, and you have a water tank too. Your guys' thing is awesome.
I don't think everything's quite kicked in right.
I
Ideally, that would sit up there. And
So we showed up and
so then you can just on clip, unscrew, slide out the back. I should start at that.
like, we need to talk to your vendor, and they want like emails from everybody. And I was like,
one that they're having other issues. It's not
You already present?
yeah, we did. I can give you a shortened version of my presentation. It's only like 5 minutes long.
Yeah, if you want to.
Yeah, I don't care.
It's just getting everything configured and so getting set up and sending emails and sort of so this would have been the key. There's no latch on it right now. If they ever did decide to buy it, just throw that over the top of it and
And you could decide whether or not you lock that or lock that or lock both. So, not having time to lock it.
It locks over there. That's all it matters.
That's right. That's right. The ability to lock is the thing that's the most important part. No, we've come a long way in the last couple of weeks. This is actually one of them I'd like to do part 2, phase 2 on.
We had a lot of the initial problems out of the way. Go and improve the functionality with it and make it work pretty.
Yeah. You guys did a really good job of pulling it all together. Really appreciate it.
Thank you very much.
Okay.
I have to find, there they are, the hay bales.
Oh.
Fancy shirts.
Always the Hawaiian team.
Hello, I'm looking for the hay bales. I go, I bought the hay bales. Oh, and the nice shirts.
We're too nervous to run in with the general public around, so.
I mean, never see it in
We have the close to the side for the presentation.
Is all the battery stuff still hooked up?
Yeah.
Have you seen the sweep along and all that stuff on it? Can I show you that?
Have fun.
We didn't. We kind of.
Yeah, take some chocolate too before you leave.
I think that's another.
That's pretty much everything we've been talking about in the presentations.
I love the Cylon approach.
Little bit. It's basically out in the same general location, but they took the fabrication from the other people and made it just the height. We added a little stop on there just so that maybe we talked about in the presentation, so it cannot raise above and allow the arms to contact its 4-bar mechanism. But say you're done with operation.
The added weight, if we went to like thicker metal or if we adjusted the bed, would probably bring that down even more, limit our run time just because of how heavy it would be. It's already, I'm guessing, when we got it, this says 300 pounds. I'm guessing we had it about 100. What do you think?
The bed's not too heavy, everything's made out of it.
And so, once it gets to a weight, you have a predetermined weight when does it send out some kind of alarm or notification to the operator?
So it gets 150 or 135 when it's operating because we want it to get more depth on the way back. So 135, it'll notify Kickstop that it needs to return home. It'll return home, notify the foreman who's there on his phone or whatever device he has his app on to come and operate, switch for that, and make sure it's in its dispensing.
And it knows to return to the next waypoint from the one it was at when it determined it was full.
That's great.
And then our obstacle avoidance, what we were able to do, because it wouldn't, the code wouldn't allow us to stop it. So what we were able to do is it goes, it detects an obstacle, does a 1-second turn about 30 degrees, scans again, makes sure there's no other obstacle, continues on to the next waypoint. So we're able to mitigate that.
What are you using for obstacle detection?
It's in this black box that's IR transmitting plexiglass. It's a letter 1 LiDAR sensor, so it sends in an electrical signal at 50 hertz is what it's set at to indicate there's an obstacle.
Awesome job, you guys. Yes.
It's been a pleasure to work for you and present to you. It's been a great project to work on.
Close flybys today.
That's a good one. Do you know anything about planes?
A little bit, yeah. My dad was.
It's an A6 intruder from the Vietnam War, man. I mean, that thing has
Looks like it's been hit.
I know. It's flown in years.
Good job.
streaming this to YouTube.
Streaming it to YouTube.
I'll be back. I'll be circulating it.
Excuse us.
Remember her? Figure out the navigator way through the roboscope. So we have to have two relays here and another relay. So we have one that controls power, one that controls direction, and then this direction actually controls the coil on this and flips it for us. So it's pretty awesome, obviously. And so essentially, you have individual controls on the trailer deck, so I can show you. And like with the, we have a simulation.
It's like living in a dog's mouth.
Higher resolution. 8-hour print, so it'll take all the design for the judges to review. So if you buy it online, it's about $20 for a roll for a kilogram. We bought this one at a printer store here in Tucson, and it was $30. This is PLA. We also have ABS, but it doesn't speak as well, so we stuck with PLA ultimately.
Maybe it's prefers like you did that, but we did.
Eventually, it's going to Ultim, so it's going to get a heated bed and it'll get an enclosure.
That's amazing.
Difficulty. It took so long to make this thing, and then printing anything takes so long, especially at large scale. If we actually want to test any large amounts of this printer, it takes days.
What are you using for slicing?
We're using Cura for slicing and Repetier for printing.
What kind of infill are you doing on something like that?
The one we're doing right now is 30% infill.
You can see the evolution.
And then the one we did before was 20%. And so this seems a lot bigger than that. But that's because each layer does both X and Y.
Yeah,
that one it does X and then Y and switches.
Yeah.
And that's pre-done. That's all done in the slicer itself.
He's gonna put the software.
So it decides that at 20% it's more efficient to do that than this.
There's the car we're printing.
I built some 3D printers myself, and nothing this crazy. This is awesome. You only have the.
There's like a streamer. You can design, you can use like AutoCAD, use any CAD software.
Hey, how are you? These guys fall around you taking pictures. Just you?
Just her entourage.
Yeah. This is going to be your, what is that? Periscope. Yeah. Actually, I should ask that. Are we doing a Periscope video for this? You've been outside, good hat.
They were very happy. I talked to the academia nuts. They were very happy. They did it with
It's a 3. We're going to have a little longer experiment. Those guys, we're not even allowed to work.
I gotta put my glasses on. So we're on, not on this row, but on the next row. Should be on the end and behind them. Looks like you've been outside too. I'm planning to go outside. Yeah.
Done.
Well done.
Have you been out to Austin's?
Not yet.
If you go out there, when he tells you about it, just ask him to say one thing. So they're like,
We're Justin. We're in Justin's department.
Perfect. Okay. I can keep just when circling. Should be back in a couple minutes.
Okay. Well, we'll make another stop by.
Okay. See ya.
You're all right. Oh, I'll get to it.
Get a sample. They're handed out to somebody else, not part of this project. From there, this guy controls the interface, so that tells it, hey, it controls the pump, it has it squeezed out at a very slow flow rate. Comes down here, this is a micro channel, we had to have fabricated. Come down the channel, and then they're counted by the so here's the detector. And then all of that registers here, there's an error, it just flashes the system, or there's an error, it just tells us, hey, there's an error, we need to check that behind. From there, the idea, and that's the scope of the project, from there, the idea would be, hey, when you have this sample now of 5 or so that you count for pushing it to the future for commercialization, the FDA would require to know exactly how many operators. So that's what they want to achieve. And they could just put them in like a tray and thermal patch you can easily develop, put them on yourself. Idea being, right, that here we're very clean. So you kind of labs and it's compared to development places or folks that have quite a
You just change it. Yeah, so ABS is so fast. So we're able to print this fast. Good work. Thank you.
These are frame crate. Crate right here costs $4 per $4 per crate, and it's a $2 million problem every year. They get about 10 uses, so it round trips to be stored back about 10 times. So they have about 40 cents per use. And they're made out of high-density polyester. So our problem was that we had to come up with something that was cheaper and hopefully less likely to be stolen, because about 80% of these are stolen compared to 20% being lost or broken. But yes, it is huge. So almost $1.6 million is lost in stolen crates per year
By this company.
for only Shamrock. It's a 3D print. It's huge. And so we were given this task, and we decided that we wanted to make a crate that had a little bit less material, a little bit more openings. So see how those golf balls are sitting in there? This one will go right through. If you have any oranges or any fruit, it'll build up and fall out right here.
Less likely for stealing.
Yes, exactly. So what we did, what we said is it's targeted more for milk, right? So it's only like the function of it is to hold milk, and that's about it. So we simulated, or we made it in SolidWorks and simulated it there, and it was pretty, it held pretty well. The deflections on both our current crate and our new crate were about the same. A little bit less on the new crate, but that makes sense with about 40% less material. When it comes out to it, you pass all of its tests, and you save about $400,000 a year.
Significant
on material alone.
And so,
It's based into the current rate that they do have. I didn't know. So even if it gets there for different rates, you can still be using this rates as well. So it has that backwards compatibility. Yeah, they do.
Oh, you're right.
Yeah, I mean, we had to model this. And we also modeled that one to run simulations to make sure that it was, very sensitive.
and what part did you do?
I have that way. Wait for the test to out one for restoration. Ran all these times here. Yeah, with the 6 gallons we decided to do the same. It's a great class, and it's so important to know, I mean, just the basics of drawing something, because you will use it eventually. And I know a lot of the other senior projects do with modeling as well, and so it's so nice.
It's one of the students project that liked AutoCAD, but I use SolidWorks gives you a better 3D. You can do 3D and AutoCAD as well, which is
It's a lot easier to navigate, when it comes down to doing stuff like this, where you want to make sure you're doing comparisons and all that.
So on the back row,
What it does is it takes
So I didn't have an issue with that, right? Somebody else did.
It's nice once it gets over, like once you see it all working at once, and then it just, because we got it to finally like all running. Yeah, so we were up late. Oh yeah, we were up late, and then our ribbon, because we had to disconnect this to bring it over, because like the enclosure isn't really part of the project, it's just like, it's just to hold it up. So the ribbon, we had to take this out, and then put it in this one. So we couldn't do it then, we had like videos. So we just PVC piped it, but manual valves.
Yeah, the wiring too is like, it looks tangled, but REs knew what they were doing. But yeah, essentially it's just like for Montana, like we had to determine hazard chemicals after their cancer diagnostics. So essentially, after the diagnostic, it kind of cleans it all off with soap and like DI water, and it drain into here. So this is like a hydrophobic filter, so it repels water, but it still saturates with oil. So that was one of our requirements, was to sequester the oil. So that's kind of done, taken out right in the beginning. And then we made an oleophobic filter, which is like never been made before. It was like a test thing on like some school's website that we went and did. And that's like this like titanium oxide and a ton of different chemicals, and just like back and forth, coating it. And so that repels the oil, so it's forced to go now. Yeah, and then all the water-based stuff comes into here, and then it fills up. So this closes, and this fills up until it gets about 7 centimeters. We have like an ultrasonic sensor that senses the range. So once that trips, this valve, if it was slow, it closed, and then the sensors would start analyzing. So this one's our alcohol sensor, and that one was our best working sensor, and we had to detect up to 24%. So we got that done. And so we set it, like we had to set all our values to where we wanted them at. And then if that passed, if there was no alcohol present, we'd move on to like the RGB sensor, which was just for dyes. And so that detects up to if there's above 0.05.
So that filters through, and then so all the pass goes to non-control, but if one doesn't pass, it goes to control, and then this would open up and drain it, and then that's what you need 5. This would open up and allow 4, this would open up. So it's just a lot of trial.
Wow, that's amazing.
I don't know what the other teams do, like the ABE teams. I haven't talked to anybody.
So there's 7 projects in which ABE students are on.
Really?
Yeah, and so if you want, Marco Miramontes is doing a helmet. Carolina.
Yeah, she's in the milk crate.
Yeah, she's in the milk crate.
She's in my breakout session.
And then Justin is doing an elbow.
Yeah, that's the one I heard.
Yeah. And then we've got the outside door in which they're doing the phase 2 of the macadamia nut.
Yeah.
Then there's a one with the remotely controlled or remotely sensed water tank levels for out in the branches.
Yeah, yeah.
And then the last one is the aerial application of.
Hey, how's it going?
Good. So is this one of our guys?
Yes, Trace.
They're all in
Oh yeah, it's great.
right now. And I'm gonna work violin. All in all.
Well, good luck, and I'll be ready.
All right. Hey, how's it going?
Lots of cool projects.
Yeah, there are.
A little distracted.
It's okay. You're allowed to be.
These guys with their augmented reality device, I think I could build that. Just off the parts they're using. It's ridiculous. And amazing.
Maybe, I'm not quite sure. Well, you know, I talked to you when you were first picking up projects, so you were doing the whole pollination of the, yeah, okay, I remember that.
Okay, all right. So
How did that go?
I think it did really well, considering they were the constraints they had to work under. Their sponsor let them use a 5-year-old.
Oh, okay, it just sounds good. Yeah, I see how that worked. And actually was able to pollinate correctly and everything?
In fact, they just got some results back, and they've increased like 90%.
Oh, wow. That's great. That's fantastic.
So tell me about your project.
Sure. So LACAS Scientific is a company right here in Tucson. They make these pressure and mass controllers. So this guy is telling how much air to put into this air cylinder or opening. The cool thing about it is, compared to their competitors, they're very fast, extremely accurate. The stability time, as you can see here, is almost negligible. Like, this thing does stabilize, but you can't even see it. That's how accurate it is. And this right here is just a few volts. It's really, really fast. What they wanted us to do is make this as a trade show piece. So when you go to trade shows and they can show exactly how fast it really does it. This was the original trade show piece. It's basically just a ball which you can put your hand on and change the temperature of the ball and the pressure and change. See, like, I can explain it to you and you understand it, obviously, but it's kind of weird. It's not exactly very, like, you don't know what you're talking about, but like, this is very obvious of what it does. Obviously, it's changing the pressure inside the cylinder and making it move to the correct position. It's very fast. Barely any time. Basically what we have is a control here. So the customer could go up to the piece and change basically where the pen is sitting. So one would be all the way at the bottom, mine would be all the way at the top, four would be somewhere in the middle, and so on and so forth. We also did it so we can have it not manned by anybody. Store button to be able to just run a randomization script and we'll just go for set points. Run it for you guys. And as you can see, a little bit of a stall here, that's okay. So you can see, it will draw you the same graph that you see up here, but they're physical. Because in a digital graph, it's very easy to just fake numbers, make something look right. Over here, you can't do it. It's obviously doing what it's supposed to be doing. But that's basically all it needs to do.
Dial like that device. We're changing the specific set points of the device that's needed for air cylinder. So air cylinder will adjust up to
And
pressure level.
wait for somebody to go. I'll make a sense.
Is the transient response.
Start the conversation and hopefully make another question.
The exciting part about it is how short it looks. Competitors take several seconds.
Thank you.
Your devices take less than half a second. So that's what you're
The only one I haven't physically seen is Justin. Oh, there he is.
He's back.
The top.
help the patient regain their full range of motion and their confidence, and it also support their continued ability to do. So the device just provides like a light course, which I use
Okay.
to assist the patient with their
Nice meeting you.
Have the connection to the app. You enter in the angle, however
That's the main thing. There you go. Beautiful. Appreciate it. Okay.
So there's some more time to find out. I have to find out if it's worthwhile for them to try and make it over by 1 o'clock. I just want to make sure there's going to be students around, projects still up. I didn't think 4 o'clock would be good.
Yeah, we got the yin yang, we got the straw.
And you follow the maze? Oh wait, I got lost.
These parts are powered by the moon. See the moon? Yeah.
Did you know that Janet, you read?
Everyone who wasn't, you're like,
That's all guys are like making changes, terrible job, shit like that.
I don't care. Anyone have any questions? Hi. How's it going? Good, how are you? Do you have any questions? God, everyone's like, that thing's awesome. How'd you bring it in here? It was tricky. It was very tricky, but Saturday? No, not yeah. You're also the sponsor from Academics, right? Yeah. How was the Academics? They present pretty well. Yeah, I haven't made it outside yet. That was one of the things I was going to try to do soon. Southeast, okay. Like southeast corner, basically? Good luck. Thank you.
I love using simple servos to toggle switches. That's brilliant.